Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will learn how to develop an assembly language program to add array of numbers. If you're a new here to my channel, kindly subscribe my YouTube channel and click on bell icon and share this video to your friends and colleagues. Let us start an assembly language program to add array of numbers. So guys, if you want to add an array of number, first of all, you should have an array predefined, or at least you should give an input from your in your input device using your input device. So now in our case, we're going to define an array with a memory location like this. This is my memory location, and from this point I'm going to define my array, and these are all my arrays like 1 1 2 2 3 3 4 4 5 5. This is my array which are going to be located in 1 0 0. This is the memory location, and then for every four memory location I'm going to add one more element like 004 008 00C, and it goes on like that. So I want to add these elements, and finally I want to store my final summation in the next consecutive memory location of 100014. So let us write the program, assembly language program, for this logic. So guys, if you want to develop an assembly language program, as I told you, you should have one memory pointer, nothing but one source address you should have where you're going to define your array. So that's what you are seeing here. So these are all my mandatory instruction. What you are seeing here, the area code, entry point, export main, all these are all mandatory instructions to initiate your assembly language program, and actual main program will start from the main. So from here onwards our main program will start. The first instruction what I'm using here is I'm going to use one memory location, that is 1 followed by 7 zeros. That is my source address where my array is going to be stored, and I'm going to load the address into the register called as R0. Okay, now so my intention is to add array of numbers, so that's why what I'm going to use here is I'm going to use one more register that is called R3 here, and that R3 I'm going to consider as move R3 comma hash 0. So I'm going to use R3 as a 0 initially as an initial sum. You can see here R3 is considered as a sum of array elements, and I'm going to consider initially that as 0. After that I'm going to use an one counter here. You can use again the same procedure, move R2 hash 5. So this is my counter. I'm assuming I'll have 5 elements in the array. Okay, now after that I need to start the first array element, load the data from the array. The first element I need to load into the one of the register. For that I'm going to use LDR, and I'm going to use a register R1 comma R0. So this instruction is going to copy the first element. So this instruction will copy the first element into the register R1, and later I'm going to add both R1 and R3. So now what I'm going to do here is add R3 comma R1. So this is going to add like this: R3 is equal to R1 plus R3. So this is how it's going to perform. So I'm going to add R3. Initially R3 is going to be 0. R1 will be first element which I copied from the memory, and I'm going to add it. Okay, now after that increment the memory pointer by 4 position. For that I'm going to use again add R0/4. So this is going to add your memory pointer by 4 position, and then I need to decrement your counter, subtract R2 is my counter here, R2 comma 1. So I'm going to decrement your counter by 1 position. This is going to decrement your counter. Now after that I need to consider here one important thing. What is that? I will tell you. So compare jump CBZ R2 comma back. Okay, so this what it will do. So check R2 0 or not, and if it's 0, jump to stop. Okay, so this is an instruction. CBZ stands for compare R2 with 0 and jump to the location which we have specified in the instruction if it is 0. If it is not 0, it will not perform. It will go to the next instruction. So just I'm checking R2 here because R2 is my counter here. So for counter, we have to, every time we're going to decrement by one value, and when it reaches to 0, it should stop. If it is not 0, it has to perform next action. Okay, if not 0, so it has to perform instruction called as a back. Okay, here I'm going to use a back. So this much is a program. Every time I'm going to check, I will add one element, and finally the sum will be available in the R3 register. Okay, here you can see every time I'm going to add. So initially first I will consider R3 as a 0. First element I will add. The first sum will be available in R3. Get the next element and add it to the R3. Sum will be updated, and it goes on like that. Okay. Finally, when it reaches to 0, you will be jumping to the instruction to stop. So in the stop, what you're going to do, stop, and here I'm going to store the store. So sum, I'm going to store it into the new memory location. So sum will be available in the R3 register, comma R0. Store the final sum in a next memory location, in the last memory or last memory location. Okay, so this is how you're going to develop the program. Program is simple, logic is simple. Only the thing is you should know logic and you should know the instruction what we have to use. So if you want to glance the program very quickly, so this is my source of an array, and then a summation is considered 0, then counter I'm considering 5 here. Every time take one data to one element to the register R1, and then add R3 and R1, store the result in R3, and increment your memory pointer by one position, decrement your counter by one position, check whether counter reached 0 or not. If the counter is reached 0, you stop it, or else you just go on executing the looping. Okay, and finally once the counter reaches to 0, you store the result in the last memory location where your memory pointer is pointing. Okay, so that is the program. Now I will add into the source group and we'll check the output. Add array. So this is my program, add array .asm, and let us check for errors here. There is no error, no problem. Enter into debug window here. Yeah, so now, so this is my memory location. I'll just define my elements here. I'm going to define some of the elements. Okay, so now let us see what will happen every time. So let us start. So now R0 should load with a memory address. Yeah, you can see the memory location address is loaded here. Then R3 should load with 0. Yes, it is loaded. Then R2 should load with 5. Yes, it is loaded. And then the first data, nothing but 111 should be loaded to R1. Yes, you can see 111 is loaded to R1 register. Then perform addition between R3 and R1 and store the result into the R3. So this you have to check it now. Yes, now you can see R3 got updated with 111. Now increment your memory pointer by 4 position. Now it will increment it to 4. Subtract your counter by 1 position. Now counter become 4. R2 is a counter here, and then since it is not 0, it's going to perform same thing. Now I'm going to add the second number, that is 1 plus 2. Now it become, the summation become 3. So again you can see here. Yes, now R1 become 3. Now now you can see your sum is updated as 6. Again, now R1 is has taken 4. Going to add with a, then now you can see the summation got updated as AAA, and finally the last one, the last data, that's 5. Then we're going to add, final answer is FFFF. Okay, now at this point, observe here, R2 is nothing but counter value is 1 now. So now if I execute one more instruction, now you can see counter reached 0. So whenever your counter reaches 0, so this condition will be skipped, this instruction will be skipped and directly jump to stop. Now you can see here, so it came to stop. So now the answer, final answer will be nothing but final summation will be saved into the 14th location. Okay, now let us see whether will it happen or not. Yeah, now you can see this is my final summation, and this final summation is loaded to the memory location where my R0 is pointing. Okay, yeah, you can see this is how. And after this, your program will end up here. So in this way, you can use assembly language program to develop your applications. So I hope this video is an informative video. If you feel this video is an informative video, please click on like button and subscribe to my YouTube channel and click on bell icon.